This is Vale. I'm from group 31 or 2. We're the baseball sabermetrics group. I'm going to try to be a little faster this time because I took 8 minutes last time. So I'm with Jackson Metavia. Here's all of our code. Um, I'll go through that in a second. Basically, what we wanted to do was look at baseball and player performance. We wanted to analyze how weather affects player performance, but also if clutch playing is a thing. So that's just how do players perform in really high stress or high leverage situations. It's pretty controversial. A lot of people argue that clutch playing isn't real or there's no statistical backing for it. So we thought that given all of the data RetroSheet has, you could do a lot of pretty powerful analysis with data mining and machine learning, maybe contribute something to the debate. So as far as our code, we split everything up into functions just to make it easier to manage. So here's, as you can see, I guess I just pointed. I have a methods to import data. So we've got methods to import the event data. So this shapes the data. This imports it. This imports the game logs. This imports the parks, the city data, the weather station data, the RetroSheet B game file data, the weather data. It's a lot of stuff. Um, I thought this was interesting. You can call read FWF directly on URLs. You don't have to call it on a file name. So I thought that was cool. For our data pre-processing, this is just a simple function to see how much we've reduced the data size by. We've got all our pruning here, so this is pruning the event data, pruning the game log data, and this is adding some features, so adding like the team, the date, the game of the day. Here's adding our coordinates. So this was all of the merging the data together. This particular cell took a lot of work. Um, so here's our k nearest neighbors fitting and assigning pairs to get the weather stations. That was pretty interesting to do. Here we've got converting our categorical numbers into integers and then downcasting them into their smallest acceptable size. Here we're doing the same to the game log data. And then here's a function that puts that all into one, so you can just call it like this. And that was nice. So here I'm not going to run this because that will take a while. But this imports all the data. -1 tells it to import everything. It takes forever. This is getting the weather data. It's its own thing because it also takes a really long time. Um, this actually, we don't use that. So here's our analysis. This is our function to calculate batting average, which is our main performance metrics. Here's the function I wrote for hypothesis testing to see if what we were seeing was actually statistically significant. Here's just getting the batting average for just regular playing, analysis on ninth inning high leverage situations, analysis on difference in scores. This was giving us some trouble, so we didn't include it in the report because it just didn't seem valid. Um, yeah, this is a batting average versus inning, more hypothesis testing on that. Some of the charts we ended up making, here's our regression line. And then here is our feature extraction using the random forest regressor, pulling out the features, sorting by importance. I guess, I don't know, you know, sorting and getting our correlation coefficients, and then you can see those here, and those are plotted here. Um, so what I think the most interesting results that I'll talk about, the weather is not super interesting because it's pretty much what you would expect. They play better in better weather. So I'm going to talk about this. The clutch playing, you can see that as the pressure goes up, they actually do better until it goes too high, and they just do way, way worse. And this was confirmed with hypothesis testing, the null hypothesis being that the batting average was going to be the red line, which is just the standard batting average. We were able to reject the null hypothesis and prove that they actually do better, but it's not a linear relationship, which I think has been a core assumption of many of the debates so far, is that like the more high pressure, the better they will do, and that is clutch playing. And I think our findings show that might not necessarily be true. Maybe it is a nonlinear relationship. Maybe uh, there is an optimal level. There's like a local maxima of like this is the pressure in which players do the best. And coaches could use that to their advantage to kind of direct how they play and how they manage their players. And so that is really the main application of this knowledge. to be honest. I mean, maybe the parks could use it to like change their ticket prices, but generally it's going to be used by coaches to know like, all right, we know this is the situation we've got, and our players are likely to not play as well, uh, and they can use that for their own strategy development. So that's our project. That is how it could be used. It's a little bit of the code. Um, Again, here's all the code. Woo. All right, cool. So that's our project. Thank you.